Welcome back. Today we're going to be doing a little bit of chemistry. We're going to be talking about solution stoichiometry. First, let's ask, what is a solution? A solution is a homogeneous mixture of two or more substances. The substance with the larger volume is considered the solvent, and the substance with the lower volume is considered the solute. An aqueous solution is one where the solvent is water. Water is considered to be the universal solvent because it can dissolve more types of substance than any other liquid. When an ionic substance dissolves in water, it dissociates. What that means is the polar regions of the water molecules pull ions from a substance and solvates them. So for example, if we put NaCl into a beaker of water, it will dissociate into Na plus and Cl minus. Electrolytes. What are electrolytes? Electrolytes are substances that will dissociate into their ions when in water. A non-electrolyte can be dissolved in water but will not dissociate. So, solubility does not always mean that a substance is an electrolyte. Ionic compounds tend to be electrolytes, and molecular compounds tend to be non-electrolytes. This isn't a rule, but generally it's a trend. Strong electrolytes. Strong electrolytes are electrolytes that completely dissociate when dissolved in water. Some examples are strong bases, strong acids, and soluble ionic salts. Weak electrolytes, on the other hand, do not dissociate fully, but they will dissociate partially. So what are some strong acids? Strong acids are hydrochloric, hydrobromic, hydroiodic, nitric, sulfuric, chloric, and perchloric. And some strong bases are the soluble salt of a hydroxide ion with alkali metals Ca2+, Sr2+, and Ba2+. And here are some solubility rules, and it shows soluble compounds on the left and the exceptions. And on the right it shows insoluble compounds and their exceptions. So what is a net ionic equation? In a net ionic equation, strong electrolytes dissociate into their ions. So for example, we'll have AgNO3 plus KCl becoming AgCl and KNO3. So first you're going to separate soluble compounds into their ions. So this is not a soluble compound, so we'll leave it as a solid. We'll split everything else up. We'll have Ag plus NO3 minus and K plus and Cl minus. And that'll become the AgCl, which we kept from before as it's an insoluble compound, plus K plus NO3 minus. Now we'll cross out the ions that are shared by both sides of the equation. This will be NO3, K plus, and we'll leave the Ag and the Cl. So our net ionic equation is going to be Ag plus Cl minus becomes AgCl. A neutralization reaction. Generally, when an acid and base react with each other, the products are water and a salt. So an example is HCl plus NaOH, which is a strong acid and a strong base. That's going to become NaCl and H2O. So let's do what we did before. Let's separate soluble compounds into their ions, which is H plus, Cl minus, Na plus, and OH minus. And then that'll become Na plus, OH minus, plus H2O. So we cross out the ions that are shared by both sides, which is Cl minus, Na plus, and then write our final answer. Our net ionic equation is H plus OH minus becomes H2O. So let's talk about molarity. Molarity is a concentration of a substance, and it's measured with number of moles over liters. That gives you your molarity. So let's talk about titration reactions. This is a technique used to calculate the concentration of a solute in a solution. This is done by using a burette to add a known volume of a substance with a known concentration to neutralize solution A. A color indicator is added to see when the reaction neutralizes. After measuring how much of the known solution was used in the neutralization, you can calculate the concentration of substance A. So here's an example of that. A 25 milliliters solution of nitric acid is titrated by a sodium hydroxide solution with a 0.115 molarity concentration. The reaction neutralizes after 18.3 milliliters is added. What was the concentration of the nitric acid solution? And here's the process to finding that out. You're going to start with what is given, which is your molarity for the sodium hydroxide solution, and you're going to use that to find the number of moles. So here's your number of moles here, 0.0021045 moles of NaOH. And you're going to use that ratio of NaOH to HNO3, which in this situation is 1. So the amount of moles of NaOH is the same amount of moles as HNO3. Next, you're going to use the moles that you just found and the volume that you're given to find the concentration of the HNO3 solution, which is going to come out to be 0.0842 molarity. Okay, so let's do a multiple choice practice problem. If 6.575 grams of NaCl is dissolved in 450 milliliters of water, what is the molarity of the solution? Our answer is going to be D, because if we have 6.57 grams of NaCl and we know that 58.44 grams of NaCl are in each mole, we can find that we have 0.1125 moles of NaCl. And we put that over our volume, which was 450 milliliters, which comes out to 0.45 liters, which is going to give us a total of 0.25 molarity, which is answer D. Our next practice problem says a 1.034 gram sample of impure oxalic acid H2CO4 is dissolved in water. This solution is then titrated using 34.47 milliliters of a 0.485 molarity sodium hydroxide solution. What percentage of the impure sample was truly oxalic acid? So let's start by making our equation, which is H2C2O4 plus 2 NaOH becomes Na2C2O4 plus 2 H2O. So let's use what is given. We have 0.485 molarity solution that is a volume of 34.47 milliliters of sodium hydroxide. So we're going to use that to find the moles of sodium hydroxide, which comes out to be 0.01672. Now let's use our stoichiometric ratio of NaOH to H2C2O4, which is going to be 2 to 1. So our 0.01672 moles of NaOH is going to become 0.00836 moles of H2C2O4. Next, we're going to use the molar mass of H2C2O4 to find the amount in grams that is actually titrated, and we have 0.00836 moles of H2C2O4 times 90 grams per mole, and that's going to give us 0.7524 grams. So we'll put that over the original amount to give us the percent, and we'll find that it was 72.8% pure. Thanks for listening. Hope you learned something, maybe even enjoyed it. Goodbye.